All right, this is Physics 1101, Fall 2022, Exam 1 Review, all right? So this will be on chapters 1 and 2, all right? So, exam I'll talk about, first of all, it'll be 26 multiple choice questions and 5 short answer problems. All right, you'll get one attempt. The problems will be graded manually by me. Once everybody's done, then everybody will get the score at that point. So that's what the test is going to be. You're going to have 90 minutes to do it, to take the test and go from there. So we'll be on D2L. We'll go from September 12th to the 16th is when it'll be open. Again, you get one attempt, so make sure you get it done right and go from there. All right? So this is what the topics will be on as far as that is concerned. So in chapter 1, all right, I'm not going to go into the details, but basically, introducing models and hypothesis. All right, what do you mean by scientific model? What do you think by theory? All right, how do models, hypothesis go into developing a theory? Then we'll have measurement on uncertainty, measurement and uncertainty. So it's basically error. All right. Significant figures. I've been through that as far as that for a number, how many significant figures are in the answer, meaning how accurate is the number. So that aspect of it, this is all scientific notation, meaning again, expressing a number as a power of 10, right? Starting with a number between 1 and 10 and a power of 10. SI units and prefixes. So make sure you know those, are familiar with those. So like millimeter, centimeter, micron, nanometer, mega, kilo, giga, and so on. So that's a little basis there. A little bit on unit conversion, but not much. We'll get into doing that. We're not going to do anything on English to metric units. All the problems we'll be dealing with will be in the metric system, but again, because most of us are still comfortable using English system, it's helpful to know like how fast in miles per hour is 20 meters per second, that sort of thing. So that's the aspect there. As far as chapter 1. So those are the basics there. There'll be several problems related to that. So that's chapter 1 part. All right, chapter 2. All right, a little bit. chapter 2. All right, displacement. Now we talk about displacement, x, velocity, v, and acceleration, a, and change of displacement, change of velocity. Again, we're using delta x. Velocity is change of distance or change of time, and acceleration is change of velocity over change of time. All right, so we'll be dealing with that. What do I mean by instantaneous? And average velocity. Okay, I've talked about that in lecture notes as far as that's concerned. And again, we're all dealing in meters per second, or meters per second squared, as we end up with the units. All right, so that's the first part of chapter 2. The second part on chapter 2, again, dealing with graphs. All right, so if you have a position, so x versus time graph, all right, what does the position mean? What does the graph mean? What is the slope? Again, the slope is the velocity. If you have a velocity versus time graph, all right, what does that mean? And the slope is the acceleration. All right, now this is for a straight line graph, but again, we can have it where a graph does this sort of thing, all right? What does the slope at different points mean as far as that's concerned? You can look at the problems for some of this. So the slope is the tangent to the line. So as we go on this curve, the slope eventually becomes like horizontal. So that's become negative, negative, 0, and positive. So at different times, what does the slope actually mean if we have a curved graph? So there will be numerous questions like that, so make sure you're paying attention to that. Interpret again some of the problems we have related to this, or problems related to straight line graphs, either position or velocity versus time. All right. As our equations are concerned, again, our equation of motion is V is V naught plus AT, X naught plus V naught. That's plus V naught T plus 1/2 AT squared, and V squared is V naught squared plus 2A X minus X naught, or in this case delta X is what that means. And if we have, that's in the X direction, and if the Y direction, then instead of X we have Y, and instead of A we have G, and G is minus 9.8 meters per second squared, or approximately minus 10 meters per second squared. All right, so we have the same graph. So for in the vertical direction, we replace A with G because that's the only kind of force we're having on it. In the X direction, the force is generally assumed to be constant, but not necessarily the same value in each case. So that's the part there. We deal with also free-falling objects. So if you drop something from a certain height, y, all right, and it takes a certain amount of time, how long does it take to hit the ground? How fast is it going to hit the ground? So we have free-falling objects there. We also have let's see here. I think that's about it. Yep. Yep. So we're either dealing in motion in X direction or the Y direction. Either one separately. So we don't have, we get into chapter 3, we'll be doing projectile motion, things like that, but that's not the aspect here. So that's really all there is to chapter 2, as far as that's concerned. I mean, there's a lot in there. Make sure you go through the problems as far as that's concerned. And that's exam 2, which again will start on September 12th and close on September 16th. So pay attention to that. The review quizzes will also close just before the exam will open. So the review chapter quizzes will close on September 12th and will not be extended. Okay, so that's it.